So while I'm waiting for parts to arrive to repair this power supply, because I can't do anything else with it right now, I could bodge in the LM317 or something like that to provide a supply, but I can get the proper part. They are available. Hopefully it's all good. Now obviously I will need to fix this rear input assembly because I want to get this working. I don't intend to use it, but it should still be functional. So what I'm going to do is take this out and have a close look at it and see what's going on, because obviously it's shorting out somehow. I don't know how, but it's shorting out. So we'll pull it apart and have a close look at that and try and determine what's going on there. There's not really much to go wrong with it. It's a pretty simple bit of circuitry. So we'll have a look. So the first thing is to get the board out. It looks like someone's already had this out because there are a couple of screws missing. And one of them was actually falling out. I've just sort of done it up again by hand, but it's definitely not right. Get my screws thing. That one stays, it's doing nothing. This one here, oh, that one's tighter. But a couple of these screws have definitely been out. So there's two, one which is missing and one has fallen out at the very least. I don't know. Maybe someone was going to fix it and decided not to. I don't know. Who knows? Maybe they thought it's too hard. So this one here was falling out before because it's just loose. And this one here, was it this one here was loose? Oh, maybe it's that one there was loose. Anyway, one of them was loose. So also I need to take the socket out as well. Need to get a proper screwdriver for this. It's quite handy having proper nut drivers. Come in really handy with this kind of thing. So a nut on the back, yes there is a nut on the back, that's going to make it a little bit awkward. I'm going to have to get onto the back of that to hold those nuts at the same time. This one's not quite going because of the sockets in the way. It's probably right. There we go. A little bit awkward, but not too bad. And now they're not stuck on the end. Tweezers. Maybe I need pliers, not tweezers. That's getting tighter. Come on. Ah. Okay, pliers those. Same with this one. Anyway. Of course it went on the floor.
Floor of doom.
Assembly free, but obviously because of the switch sticking out now I need to take the front panel, or the rear panel off in order to get enough movement to actually get that board out. Not a big deal, just a little bit inconvenient. Come on, that's a bit tight. Because I'm sitting on it. Right. There you go. I'll try and drop the board out. Yep, that'll work. It's all rather fiddly. I'll take this whole rear panel off. Come on, just like a little bit more movement. There we go, right. Here it is. So this does different options as well, it does other things. It's not just the rear input. You actually have this same module does the ratio input as well with extra connections on it. I think it's got extra relays go on or something. All that information is in the service manual, so I suppose in theory you could actually build this up to become the ratio module. I guess. I've got no idea what this thing is, I need to look into that. It's a bit of a weird custom IC thing. So, here we go. Like I said, there's not much to go wrong with this thing. There really is very little to it. So we have this connection here, this one here, this one here. Now this one and this one here, those are the pass-through for the front panel connections. Okay, so you normally, well, these go out of the unit, and these are the inputs from the front panel. Okay, so the front panel come down to here, with the front jacks, banana jacks on the front posts, whatever you want to call them, and then these obviously the rear inputs, and here's the pass-through which then go out. Alright, so this is just the control circuitry here for the actual switching. So that isn't actually needed. Question is, what's this bit doing? Alright, now I think this is all just really just switching these relays. I think that's all it does. So we've got supply rails on here, plus and minus 15 volt on a common, and I think there's like some thing there to say, you know, identify it on the circuit or something. So I need to look at the circuit diagram for this and actually understand it. It's basically 3 transistors to switching 2 relays, and that IC, whatever the hell that's doing. Another diode down here. So I could do some basic checks and just check things like tantalums for being shorted. Although there's no discoloration, so it's not likely. But I did already probe onto this diode, whatever the hell, I think there's a diode across there, to make sure that's not shorted, and I didn't seem to be anything there. But that's before I actually understood a bit more about how it actually works with it being across those rails. So that's the front rear switching there, right? So that is just controlling this board, which is then controlling these relays. That's the way I'm interpreting it. So I've got that wrong. I'm just trying to follow the circuitry around, actually. So the relay coils be these ones here. Yep. So the relay coils come around to these transistors at the top here. So right, so one comes across, splits out. So there's one going to that, which is also going to negative diodes. It's probably a suppression diode. And then one comes up here to the end of that diode. So if I check all these diodes, maybe it's a blind diode, it could be shorting out. I mean, those obviously just for suppressing the relays, but it's actually really tempting to build this circuitry up to fully populate it and make it a ratio board as well. Very tempting, if it's possible. Depends what this chip here is doing. Well, according to the service manual, this is an MC14013, which is odd because that is not what that device is, unless it's a previous variant they made. I don't know, I'm confused by that. Yeah, it's a bit strange. There's obviously a chip on board. For some reason I made a custom board for that anyway. So we'll go through and test the diodes and see if we can find any obvious faults. But I mean, it's definitely shorting out the power supply. At least it was. Maybe it's shorting out because the 15 volt rail was missing. But that doesn't really make a lot of sense. It shouldn't really do that. Stranger things have happened. Anyway, let's check for shorts. We'll use continuous. Actually, let's do diode check mode. Let's do it in diode check. So we're going to check diodes. Might as well use the right mode. Okay, so this diode here. Probably because it's got parts around it. It's a bit leaky that way, but not much. It just looks correct in the other direction. Let's check this one. That looks correct. That looks correct. That looks correct. Other way around, nothing. Nothing. And nothing. And one more diode over here. That looks correct as well. And yep, that looks right. So diodes are okay. That narrows it down quite a bit. There's not much else to short out on here. Tantalums, that's always a prime suspect. 0.8 so across that one. 2.1 across that one. Depends on what polarity I've got set up on here. I'm using backwards, I suppose. Let's do that way around. 1.3 volts in the correct polarity. 0.7. Yeah, no, suspicious. Capacitance. I don't think it's 128 microfarad somehow. That is a 10 microfarad. Bit of a difference. Let's check the next one. 2.4 microfarad. I think it's 4.7. Be hard to see. And the next one is, didn't know it's 15 volt. I can see that much. No, I can't read it. See what we get anyway. Yeah, that's 330. That's definitely not right. Okay, well, tantalums aren't dead short, but let's do resistance measurements across them, see what happens. Nothing there. Nothing there. This is on the continuity mode. Nothing there, so nothing showing short there. Okay, let's check the transistors. That looks correct. That looks awfully low. Could be circuitry around it though. No, okay, maybe it's that way and that way. Right, it's probably the base over here. Yeah, I think that's probably the base there. Just assume the same pin for these ones as well. Nothing there. Nothing there. 0.6. 0.6, yep. I think it's got NPN and PNP variants of the same transistors. 0.6. 0.6 and backwards. Nothing. Nothing. Okay. Slightly suspicious about this one, but that first value. Of course here, 0.2 instead of 0.6. I'm getting 0.6 there now. Maybe I was probing something, maybe I was touching something else. I don't know. Okay. Or was it that way? I got it that way. Okay, that's what it was. Emitter collector. Could there be an issue there? That looks similar. Is that leaky? Both directions? Possibly. Which connections are going to? That one there. Which is, I don't know which pin that is that pin 1? I'd guess that's pin 1. Yeah, there's a one up here, so that's pin 1. And the other connection, try and trace that through. I could look at the circuit diagram, but it's more fun looking at this. Through there, comes to the resistors, so it doesn't go back to there. So that's probably okay. Is it a solder bridge? There's a solder bridge across here. I don't know if it's meant to be there. No, there's a trace, it's fine. It's meant to be there. Thought I found something then. Okay, well, let's check this cap. It's really unlikely to be this one. Nothing going on there. And check this one. .6 volts across that cap. Really? Very odd. Come on, can't probe it. 2.4 volts, so polarity dependent. What else across? Might be across something else. Yeah, it is. So, that narrows down, it's probably this chip. Could try powering it on and see what gets hot. If you look closely at this one, it looks like it's actually been lifted out. It's not actually seated properly. slightly wonky, and it doesn't look like it's bedded right then. One side's down a bit more than the other. I wonder if someone's had this out. Mental note. The blue line of that diode, or I'm guessing it's a diode, comes towards this corner here. In case I get messed up with polarities or something. I'm pretty sure this is in backwards. Reason being, if you look underneath it here, there's pin 1 marking right there. Well, that makes that marking in that pin. But if you look carefully, I can see it, the cutout is here to mark pin 1. So that's pin 1 over here for the socket. This is in backwards. I'm pretty sure that's not a good thing. Well, I just checked against the service manual, and yep, sure enough, this pin marking here as pin 1 being at this end is correct. So yes, if that pin 1 marking on this device is correct, this is in backwards, and it runs with the minus 15 volt rail to the chassis ground. Well, it's a 0 volt rail. So that would be shorting out the minus 15 volt rail, which is what I observed when this was plugged in. Hopefully the diode that's on here has protected it and it actually still functions. But why would someone would take that out and put it back in backwards? Gotta wonder. So let's check it across these pins. So let's see if this is looking like it's survived. Nothing that way, which is what it should be. And diode that way, 0.5. It's likely that survived. Well, it's possible it survived. Yeah, not particularly convenient now, is it? So what I can look at doing, I don't actually need to hook these connections up. All I actually need to do is hook up this one. I can plug this back in again, hook this connection up, not hook up anything else, and I can see if it will function. See if it switches, and see if it's recognised maybe. I'm not sure. I'm not actually sure what this does. It obviously communicates with the main processor somehow, but I don't actually know why, because it doesn't need to. If it's a switching an output, like this switch here, and these transistors are switching the relays to switch the inputs in and out, right, for the front and rear inputs. Does this have a second function? I'm not really sure what the point of that is. Why does it need this complexity here? Anyway, we'll put this chip back in again, and if we're lucky it's not completely dead. It's always fun working on something somebody else has already worked on. Well, I've hooked everything up. I've just sort of plugged it in and precariously balanced it on the back here, and operating the switch is switching the relays. Well, you can't see that. That's definitely switching. Don't fall off. Stay there. Let's check the power supply. That's not getting too hot. Before it was getting quite hot quite quickly. That feels fine. Be careful when you're sticking your fingers around here. There are high voltages in this area, so be careful where you're sticking your fingers. Don't just shove them in there willy-nilly. You might zap yourself. I know that touching this is okay, and that's fine. I'm happy with that. Checking everything getting hot. Feels fine. Nothing getting hot. So maybe that's all that was wrong, was that chip was put in backwards. Yeah. Alright, so it's the rear input basically fit back in again. I've got to get some more screws to replace our two which are missing here, and then I can redo these connections, and I think that'll be alright. I think that's probably fixed. Alright, let's try and get these connections back together. I've already done one. Well, put one of the connections on. Just need to move these other ones out of the way and refit the front ones back onto this board that passes through this board. I mean, if you're not even using this option, you don't really need to worry about it, but I like to have things as original as possible where I can. So let's see, I put the board onto there. I'll plug this into here, and that should then re-enable that feature. All good. So the good is then is make sure that you got the switch here in the correct position, which is in my case it's going to be to the front. I've already put those two screws in which are missing, so I think that is repaired, that section. I've still got to do the power supply obviously, so yeah. So if you're enjoying this repair so far, make sure you like the video, give us a thumbs up, and subscribe and click the bell icon to get notifications about future videos as well. So it's really important you do those things because it does help the channel and also helps to ensure that you don't miss my future videos. I've also got loads of videos in the back catalogue, so make sure you go and check those out as well. Hundreds and hundreds of them with various repairs and bits of test gear and things like that. So anyway, so it's interesting working on this thing, trying to figure out what its faults are. I mean, that chip there installed backwards. Who would have thought it? Right, so to confirm the functionality of that rear input now and make sure it's actually switching, I've just got my tweezers shoved in here for now to create some kind of short. I'm in kiloohms range. Also supply my external power supply to keep the thing alive. You can't quite see it, but here you go, probes on the back there. So I switch between the front inputs, which is what's currently set to, and the rear inputs, and it should go open circuit. It has. It's floating. Okay. It's auto ranging. Interestingly, that's still looking at those, I think. Maybe it's slightly different for resistance. No, it isn't looking at it. Input there on the front. It's there. Rear input. Definitely changes, but it's not going completely open. Is there a reason for that? So that's used on 2-wire, 4-wire. Not sure that's right. Or is it just floating noise? I'll touch the terminals on the back. Yeah, I'm getting the differences there just by touching the terminals. There we go. Don't know, maybe there's still something going on there. I'll have to research that slightly more. That's on megohms now. So we'll do 1 ohm. Sorry, 1k. Short front out, go to the rear. So is that normal? I haven't really tried. Okay, I think I know what's going on here. When you're on the rear inputs, it uses 4-wire all the time. So if I have this set of 4-wire on the front here, I'll get exactly the same behaviour on the front inputs, right? So it'll be, oh, now I've done that, it's going to say something else. There we go, floating up, right? Then I open it up. It goes error OL. Alright. So it's floating. Oh, now it's not floating. No, it's floating. Sure, those ones out. Kind of floating. Your inputs still floating. Alright, so switching the relays doesn't change anything. But if we go to 2-wire, front input, then it does OL straight away. Rear input, if I do that, then go to rear input, it floats. So I think it does 4-wire from the rear input regardless of what the switch on the front is setting. I think that's 2-wire only from the front, otherwise it's 4-wire from the front and 4-wire from the back. I think, based on what I'm seeing here. There could still be something going on, but at least it's kind of working. It's not getting hot and overloading the power supply now. Let's check. Yeah, it's barely warm. It's fine. So I've had a really close look at the circuit diagrams and the service manual for this board here. It's the same board and everything, the whole assembly is the same as the ratio input board. It is the same unit. The only difference is it's got the extra populated resistors and transistors and stuff like that. So with the aid of the circuit diagram, it's actually possible to add ratio to this thing. Very easy to do it. All you need then is some kind of connections on the back to be able to do that, but it's possible. All you need is a couple of relays, which are of the correct type obviously, and you've got the ratio input selection stuff. Or is it this one here? I can't remember which one it is now anyway, but yeah, the might be that one there. Users, so very easy. Also I was looking at the circuit diagrams and it looks like the analog output here, which is also an option, that board would actually be quite easy to make. There's not much to it. There's a couple of op amps on it and a few discrete components and stuff like that. Nothing too complicated. So I actually reckon that it's possible to make the analog output board as well and actually fit that later on if you really wanted to. All these little options, I like to tweak things like that. I like to tinker. So maybe I will make something. Maybe make a modern version with modern parts, so it's not using obsolete parts. I mean, it is just a relative output level. It's just a 0 to 1 volt level apparently, relative to the input, I think, or relative to the measurement being taken. Something like that anyway. I don't know about that too much. I haven't read too much into it, but that looks like it's buildable. This looks like it's modifiable to add the ratio. Looking pretty easy. So that's interesting. I'm also thinking maybe, because I don't know which one of these 2 meters to keep once I finish fixing them both. I've got the, obviously this is the LS101, which had that really disgusting front panel, which still doesn't look wonderful. The other unit's got a perfect front panel. It looks mint, and I will get them fixed too. But now I'm sort of mixing, well, I'm a bit torn between which one I keep, because the LS101 has got a better AC board. Alright, apparently it's got higher accuracy. Alright, so the AC board on this one is much larger. On the other unit it's only this wide. It doesn't have as much resolution. So although it works obviously, but this has got better accuracy and better resolution. So it's not, I'm kind of torn. I mean, do I strip this board out of this unit and put it into the other one and take the rear input thing here, put it into the other unit and keep that unit as my unit and sell this one on with a different AC board in it? I mean, then people might be expecting to have the high res AC board in it, but it wouldn't have it. I mean, I don't know, I don't like to do that kind of thing. I'm definitely tempted to keep the better unit for myself and sell one of the units. I mean, they've been parts swapped anyway. Who knows what's original, but this is an option, so taking it out's not really an issue. I could always put it in the other unit and that's absolutely fine, because that is an option anyway. It's not necessarily installed, so that's not a problem. But removing the decent AC board and put it in the other unit and swapping them over, I'm not so sure about that part. Yeah, but then also then removes the ability to have the current sensing added to it later on, because current sensing goes in this section here. And obviously once you've got this board in there, you can't fit the current sensing because it just physically doesn't fit. So there's a few trade-offs there about what to do. I mean, I'm going to get them both working. I will fix them both. I'm confident of that. I mean, this one's 19% there, you know, with that power supply repair. Once that's done, it'll be good. Obviously the GPIB is a problem. I need to sort that out. So yeah, we'll see. I'm just not sure yet about how I'm going to handle this, because I want to keep one unit and sell one, but obviously I want to keep the nicer unit. And the front panels are different, you know. This one's obviously in a much worse shape than the other unit. This one's, you know, obviously where I've repaired this one, it's better. It's a huge amount better, but it's still not wonderful compared to what the other unit's got. It's a bit of a trade-off really. You know, which one do you go for? Do you go for the one that's got better cosmetics, or do you go for one which got better features? I want both. And now I can't really just swap the front panels over, because that would be an easy solution. Just swap the panels, put a nice panel on this unit. There's some differences on the button functions. So on this unit here, we've got current marked on the front panel, which is interesting, seeing as you can't actually have current on this unit. So I don't actually understand why that's even there. On my other 1062, that same button is marked as rear input. So I don't know, go figure. It's got a current feature you can't have, or a rear input button, which it also can't have because it's done a physical switch on the back. Yeah, I don't know. Actually, that's the point. I just thought of something. This can't be put into the other unit because it's got the physical switch on the back. It's slightly different to the other one. That doesn't have a position for the switch. That's using electronic switching instead. Maybe there's a way of doing it. I don't know.